7.3 exponential and logarithmic equations. With these, we are just solving and checking. Sometimes we're going to have exponents, sometimes we're going to have logs. With them, you can always make sure that when you have exponents, like with example A, you want to turn your bases into the same number. So for A, we have 8 to the power of x is equal to 2 to the power of x. The whole idea is to get the bases to be the same power, so that way the only thing you have to work with is those exponents. So 8 is the same thing as 2 to the third power. Then that means that we would have two bases that are the same. So 2 to the third power, that x as the power is going to be multiplied with the 3, is equal to 2 to the power of x plus 6. Now, since our bases are the same, we can cancel them out and just set our exponents equal to each other. So 3x is equal to x plus 6. We would subtract the x from each side. We have 2x is equal to 6, and then we would divide each side by 2 to get that x is 3. For example B, we have 5 to the power of x minus 2 is equal to 200. Now, 200, you can't turn that into a number raised to a power. So we are going to take the log of both sides. If we do this, we're going to have log 5 to the power of x minus 2 is equal to log 200. Remember, when we have an exponent on a log, it becomes the so-called coefficient to the log. So this is going to be x minus 2 times log 5 is equal to log 200. From here, we're going to get x by itself. So we are going to divide each side by that log 5. So this is going to give us x minus 2 is equal to log 200 over log 5. From here, we just add the 2 to both sides. And we are going to have x is equal to log 200 divided by log 5 plus 2. Now, use your calculator for this. If I do log 200 divided by log 5, I get 3.292029674. From that, I'm going to add that 2 to it and round to the nearest hundredths. So if you are doing this, you should be getting x is equal to 5.29. For C, we have 3 to the power of 2x is equal to 27. So 27 is also 3 to the third power. So we can rewrite this as 3 to the power of 2x is equal to 3 to the third power. Our bases are the same here. Those 3's are the same, so we can cancel them out and only work with the 2x is equal to 3. Divide each side by the 2. We have that x is equal to 3 over 2. For D, we have 7 to the power of negative x is equal to 21. Once again, we can't turn 21 into the power of 7 or 7 to the power of something. So this is going to turn into log 7 to this negative x power is equal to log 21. So remember that negative x becomes the so-called coefficient. So negative x times log 7 is equal to log 21. Get x by itself. Divide each side by log 7. So negative x is equal to log 21 over log 7. Now from here, you would do that and then divide each side by a negative. So then divide by the negative. So we're going to do this and then divide it by a negative 1. So x is going to equal log 21 divided by log 7 divided by negative 1. So in your calculator, do log 21 divided by log 7, hit the enter button, and then divide that by negative 1. You should be getting x is equal to negative 1.56. Again, we're rounding to the nearest hundredth with these. For E, we have 2 to the power of 3x is equal to 15. Again, that 15 can't be turned into 2 to a power of something, so we're going to take the log of both sides. So log 2 to the power of 3x is equal to log 15. The 3x will go in front of the log and be multiplied, so 3x times log 2 is equal to log 15. We divide each side by log 2. And then we have 3x is equal to log 15 over log 2, or divided by log 2. From here, we are going to divide each side by 3. So in your calculator, we're going to type in log 15 divided by log 2 divided by 3 after we find that. So first, log 15 divided by log 2, that gives us 3.968, so on. If we divide that by 3, we get x is equal to 1.30. For f, we have 3 to the power of 2x is equal to 5. Again, we can't turn the 5 into 3 to the power of something, so take the log of both sides. Log 3 to the power of 2x is equal to log 5. The 2x goes in front, so 2x times log 3 is equal to log 5. We are going to divide each side by that log 3. So we have 2x is equal to log 5 over log 3. We are going to put parentheses around this and then divide it by 2, because we have to divide each side by 2 to get x by itself. So in our calculator, we're going to do log 5 divided by log 3. Hit the enter button and then divide by 2. So log 5 divided by log 3 is 1.46, so on. If we divide this number by 2, we get that x is equal to 0.73. For these next ones, we have equations that have log in them. When we do that, if we want to get rid of the log, we're going to take the base on the log and set each side to have that base. So for like example A, we have log 3 of x minus 5 is equal to 2. 3 is our base, so we want the 3 to be the base on each side. So we're going to do 3 to the power of log 3 of x minus 5 is equal to 3 to the second power. Now, that 3 and that log 3 cancel out. So anytime you have a base raised to its log with the same power, they cancel out. So the only thing we have left on this side now is that x minus 5, and then we have the 3 squared. The 3 squared is 9, so x minus 5 is equal to 9. We move the 5 over by adding it to both sides, and we get that x is equal to 14. For B, we have log 45x minus log 3 is equal to 1. Remember, when we are subtracting, we are really dividing. So keep the log, divide 45x by 3, keep it equal to 1. So the 45x divided by 3 goes into 45 15 times. So that's log 15x is equal to 1. You have a base of 10 here because there's invisible base. There's no base, so it's an invisible 10. So we're going to take 10 and have that be the base on each side. So from here, that log with that base of 10 is actually going to cancel out. So the only thing that we have is going to be the 15x is equal to 10 to the first power, which is just 10. So then from here, we divide each side by 15, get the x by itself, and x is equal to 10 over 15, which is the same thing as 2 over 3. For example C, we have log 4 of x to the second power is equal to 7. So we're going to start by taking that 2 and bringing it out in front of that log 4. So 2 times log 4 of x is equal to 7. We would divide each side by the 2 to start with. So we have log 4 of x is equal to 7 over 2. Now is when you can go ahead and have each side have a base of 4. So we're going to have 4 to the power of log 4 of x is equal to 4 to the 7 over 2 power. So from here, we're at that 4 and that log 4 are going to cancel. So x is equal to 4 to the power of 7 over 2. Now take this and use your rule of exponents. The 7 is your power, the 2 is your index. So this is the square root of 4 to the 7th power. The square root of 4 is 2, and 2 to the 7th power gives us 128. So x is equal to 128. For D, we have log x plus log times x plus 9 is equal to 1. So remember, when we do this plus or the addition, we are multiplying the x and the x plus 9. So we're going to have log x times x plus 9 is equal to 1. We are going to distribute this x. We get log x squared plus 9x is equal to 1. Our base here is 10, so we're going to rewrite this as 10 to the power of log x squared plus 9x is equal to 10 to the first power. So the 10 and the log cancel out, so we have x squared plus 9x is equal to 10. We move that 10 over by subtracting it from each side, so that way we have it equal to 0. So x squared plus 9x minus 10 is equal to 0. Then we go ahead and factor. The factors of negative 10 are 1 and 10. The 10 would be positive, the 1 would be negative in order to give us a positive 9. So this is going to be x minus 1 times x plus 10 is equal to 0. We set both sets of parentheses equal to 0, so x minus 1 is equal to 0. X plus 10 is equal to 0, and then we solve. Move the 1 over, add it to both sides, so x is equal to 1. Move the 10 over, subtract it from both sides, x is equal to negative 10. So we have 1 and negative 10 that are solutions for this one. But when you are working with logs, negatives don't work. So this negative 10, we would actually take that and not have that be an answer because of the negative. You cannot have negatives here. If we look at our next example, we have 3 is equal to log 8 plus 3 log x. That 3 was originally the exponent on the x, so we're going to move it back to be the exponent on x to give us 3 is equal to log 8 plus log x to the 3rd power. Because we are adding here, we're really multiplying. So this is the same thing as 3 is equal to log 8 times x cubed. 8 times x cubed is 8x cubed. So 3 log 8x cubed. Now, we can go ahead and rewrite this as, 3 is equal to, the base on the log is a 10. So this would be 10 to the 3rd power is equal to 10 to the power of log 10 times, or of 8x cubed. So the 10 and the log 10 cancel. So we're left with 10 cubed, which is 1,000, is equal to 8x cubed. We can divide each side by that 8 to get the x cubed by itself. So x cubed is equal to 1,000 divided by 8. We take the cube root of each side. The cube root of 1,000 is 10, and the cube root of 8 is 2. So that's 10 over 2, which is also 5. So x is equal to 5. for f, we have 2 log x minus log 4 is equal to 0. So that 2 is going to become the exponent again on that x. So log x squared minus log 4 is equal to 0. Because we are subtracting, we are going to divide these two. So we're going to have log of x squared divided by 4 is equal to 0. From here, that log has a base of 10, so we're going to do 10 and 10 on each side to be their bases. That 10 and the log 10 are going to cancel, so we have x squared over 4, and 10 to the power of 0 is 1. We would multiply each side by 4 to get x squared by itself, so x squared is equal to 4. We take the square root of each side, so x is equal to plus or minus 2. Once again, we can't have a negative here, so x is just equal to 2.